right, so continuing our notes from yesterday, Unit 9, Topic 3, Growth and Decay. We did the growth parts yesterday, which were 12 and 13. And now we're on page 14 where the decay model's at. So a lot of these parts are going to be the same as they were yesterday. The only difference is now we have a subtraction. So looking at the different parts, we're going to label it again. So right here, the A value is your starting number. So we say that's your initial amount. The R is your rate. And again, usually it's given as a percent, but we need to change it to a decimal. The T is the time in years. And it's not going to ask us this time, but this one, like we talked about yesterday, is now called the decay factor because it's going to be less than 1 since I'm subtracting it from 1. So you do this one when it says that it decreases, depreciates, declines. We're going to use this formula right here. So looking at our first example, it says a new television costs $1,200. The value of the television decreases by 21% each year. So here, is that all of it? I want to see all of it at the same time. So we need to first write out our formula. Okay, I'm not going to be able to see that bottom part, but we can move it. So we got to decide, is it growth or decay? So since it says that it decreases, then I know it's going to be a decay model. And I want the one above 1 minus R to the T. Your A value is what you start with. So the new TV costs $1,200. That's going to be the A here. And then the rate that it declines at or decreases at is 21%. So again, 21%. We want to move the decimal place back twice. So R is actually 0.21. So that's the number we plug in here for R. So if we set up the numbers, A for our equation is 1,200 times 1 minus the R. I'm going to put my T power, and R is 0.21. So if we subtract 1 minus 0.21, we get that the equation is 1,200 times 0.79 to the T. So we're going to use this equation for B, C, and D. So for part B, it says estimate the value after 2 years. The 2, since it's years, it's giving us the time. So we're going to take our equation and we're going to plug it in for time. So 1,200 times 0.79 to the second power, so squared. So then we just type this one exactly into the calculator. So back on the calculator, we're going to go 1,200 times 0.79 to the second power. And we get that the cost is, this is cost $748.92. So this one I can actually round to 2 decimal places since we're dealing with money. All right, and then answering C and D, I'm going to go ahead and just copy the equations down there for C and D. So here it says estimate the value of the television when the television will be $300. So taking our equation, we're going to plug it into y equals. So because 300 is giving us the y, we want to plug it into y equals and estimate the year. So we're going to do, what was the equation? 1,200 times 0.79 to the x power. And we want to see when does X equal 300 or about 300? It's not going to be exactly 300. So in Y equals, go ahead and type it in. 1200 times 0.79 to the X power. Use X here. And you use the graph. So go until the number is below 300. So right here is when it starts getting under 300. So we would say that this one is 6 years. We will find more exactly once we learn how to solve, but right now we're just estimating. So estimate. All right, estimate the value after 15 years. So for this part, 15 is giving me time, which is the X. So here I'm gonna plug in, but since I already have it in the calculator, I'm just gonna go down to where X is 15 and see the price there. So when X is 15, Y is $34.96. So this is money. Or you could have just plugged in 15 as the exponent. Now, as far as reasonableness goes, is this a reasonable amount for a TV? I mean, just because this is what it says mathematically, it might not be what happens in everyday life. So reasonably, probably not. Because after 15 years, the TV's probably broken, or it doesn't work, or there's new models out. So we say this one's not reasonable. Because this is so far. I mean, technology changes so quickly that in 15 years, the TV we have now is probably not going to work. Or, I mean, it's going to be a way better version. So it's not going to be worth anything at that point. So we call this extrapolation. So extrapolation is the process of estimating beyond the original data range. So usually with these exponentials, 10 years, going up to 10 years is getting pretty unreasonable. Sometimes it'll be okay. But usually we don't go that far. We don't go to 15 because then we get these prices that really don't mean anything. So this is subject to uncertainty. And a higher risk of meaningless results. So we can get it to a penny, but again, that's probably going to take 100 years, and at that point, it wouldn't. I mean, it'd be a classic because it's really, really old and really, really nice, or it's in the trash. So that's why we don't do the extrapolation.